Hi everyone, in this video I'm going to show you how to do the reciprocal of a linear function. Now first of all, what is a reciprocal? A reciprocal is basically the fancy math way of saying 1 over a number. And so the basic reciprocal function then is f of x equals 1 over x. Now, often when you encounter a new function, the best way to approach it is with a table of values. So that's what we're going to do. I'm going to actually make a table of values in 3 parts. We're going to do x, we're going to do y equals x, and we're going to do y equals 1 over x. Okay, and these will be the values that we're going to look at. Now I know what the 1 over x function looks like, so I'm going to choose my values carefully. I'm going to do -3, -2, -1. I'm going to do -1/2 as well. 0, I'm going to do +1/2, 1, 2, 3. And these are often really good numbers to pick if you've got a function that you know absolutely nothing about. Often functions do different things around 0, and so having fractional values close to 0 are often useful. And because I know where this is going, having these values I know for 1 over x is going to be useful. Now, first of all, our y equals x function, y literally equals x. So if x is -3, y is -3. If x is -2, y is -2. If x is -1, y equals -1. So this might seem a little bit silly, but the idea of y equaling x is actually a really important function. It's actually one of the most important functions. It comes up a lot. And so if we graph this y equals x on our x and y axis, let's call this x, we'll call this y. Our y equals x function goes through 0, 0, and if x is 1, y is 1. If x is 2, y is 2, and so on. It's the diagonal line that goes up at 45 degrees and down at 45 degrees. That's y equals x. Now our 1 over x function, 1 over -3 is -1/3. And 1 over -2 is -1/2. And 1 over -1, well, 1 divided by 1 is itself, it's just 1. So this is just -1. Now, 1 over -1/2, it's going to be negative. And if you imagine 1 over -1/2, that's the same as 1 divided by -1/2, which is the same as 1 times 2 over -1, which equals -2. So this is -2. Now what happens if we get close to 0? Well, you actually can't do 1 divided by 0. 1 divided by 0 is undefined. So we're just going to write undefined here. Okay, and our positive values are basically going to be the exact same thing except positive. 1 over 1/2 is going to be the same as 1 over -1/2 except without the negative sign. So it's just going to be +2. This one's going to be +1. This one's going to be 1/2, and this one's going to be 1/3. And so hopefully you can see what's going on here. This point here at 3 becomes 1/3. Oops. There we go. And our next point here is 4. Well, what would 1 over 4 be? Well, 1 over 4 is literally 1/4. And 5, 1 over 5 is 1/5. And so if you can imagine going over and over and over, let's say we wanted to know what f of 1,000 was. Well, f of 1,000 would be 1/1000th. Or what's f of 1,000,000? Well, f of 1,000,000, like our function is 1 over x, right? So it's literally 1 over 1,000,000. And so these numbers are going to get close and close to 0, but it's never actually going to reach 0. And so that means that in this right-hand direction, we have what's called an asymptote of y equals 0. And this is our asymptote. And if we do our negative graph, let's sort of start at our end here. So -3, the reciprocal of -3 is -1/3. And the reciprocal of -4 is -1/4. And the reciprocal of -5 is -1/5. And so again, our function is going to get close to the line y equals 0, but never actually get to the line y equals 0. So you can get as close as you want to 0 without actually ever getting to 0. And so that's the idea of an asymptote. And now let's sort of work towards our middle. So on this side here, the reciprocal of 2 is a half. The reciprocal of 1, well, 1 over 1 is just 1. And we saw the reciprocal of a half is 2. So now what I want you to do is I want you to imagine this point here that is 1/10, 1/10. Well, what's the reciprocal of 1/10? So if we do the reciprocal of that x value 1/10, we're going to get 1 over 10, which is 10 over 1. So 2, 4, 6, 8, 10. That's this point way up here. 1/10 of the box over, it's 10 tall. And so it's actually going to shoot up basically vertically as you get closer and closer to the y-axis, and shoot off horizontally as you get closer and closer to the x-axis. And similarly in the negative direction, reciprocal of -2 is -1/2. Reciprocal of -1 is -1. The reciprocal of -1/2 is -2. The reciprocal of -1/10 is -2, 4, 6, 8, 10. And so our function approaches the x-axis and then approaches our y-axis. And so because it approaches the y-axis, like you can imagine having a point like right there, right off of 0. That's like 1/1,000,000th by 1/1,000,000th. And 1/1,000,000th, 1/1,000,000th, the reciprocal of that is 1/1,000,000th, a million. And like there's an even closer point at like 1/1,000,000,000th tall, which would be a billion up. And so you can get as high as you want just by doing 1 over that number away from the x-axis. And so you also have what's called a vertical asymptote of x equals 0 is your other asymptote. Oops. There we go. So an asymptote is a line that your function approaches but does not cross. And reciprocal functions, anytime you're dividing by your variable, well, if your variable was 0, then you can't divide by 0. But if you put a number that's just a tiny, tiny bit off of 0, you get like 1 over something teeny, teeny, tiny, and 1 over something teeny, teeny, tiny is something huge, right? It goes up to like positive a million, right? F of 1 over a million is a million when you do your reciprocal. Okay, so that is a basic 1 over x function. So how do you graph a linear equation in a general form? How do you graph its reciprocal? And essentially the points that we care about the most are the points where it goes through the x-axis, because where it goes through the x-axis is the 0 of the function, and 1 over 0 is essentially plus or minus infinity. It's undefined, right? You cannot do that. And as you get just a slight tiny, tiny bit to either side of that 0, you either go to positive infinity or you approach negative infinity. So let's try, I don't know, some other function. Let's do g of x, I guess. Let's do the next letter, equals -3x plus 6. Let's do one that has a nice x-intercept we can find easily. So if we sketch this linear function, we're going to have 1, 2, 3, 4, 5, 6. We're going to have a y-intercept at 6, right? There's our b value. And our -3 value means it goes over 1 and down 1, 2, 3, right? That's the slope. A slope of -3 means that our rise is -3 over our run of 1. Okay, so over 1 is your run and down 3. Over 1 is your run and down 3. And working backwards, we can go back 1 and up 3. And so this right here is the graph of g of x equals -3x plus 6. So now let's make h of x to be 1 over g of x, the reciprocal of the graph function we just did, which is 1 over -3x plus 6. So how do we graph the reciprocal of this? First of all, let's do these positive integer points first. The reciprocal of 9, 1 over 9, is 1/9. The reciprocal of 6 is a sixth. Oops, a sixth. The reciprocal of 3 is a third. Now, the 0 I can't do, but right next to the 0, I've got some teeny tiny number. It doesn't matter what it is. Let's call it, I don't know, 0.001. Whatever it is, it's going to shoot up to a vertical asymptote there. And similarly, on this other side, it's like a negative teeny tiny number. And 1 over a negative teeny tiny number approaches negative infinity. And so we're going to put in a vertical asymptote. Let's do, that's a pretty color. There we go. So there is our vertical asymptote. And in this case, the equation, this is 2 on the x-axis. So this asymptote is x equals 2. And we approach it on the left-hand side. We approach sort of positive, infinity, whatever. Now, I want to go through the point here that's a 1, right? Because 1 over 1 is itself. And so this point here is called an invariant point. It's not that big a deal in 20-1, more of a big deal in 30-1, but might as well learn it now. And this point here, -1, is also an invariant point. Okay, so we're going to go exactly through that point. And knowing that that point there we're going to go through, and here we're going to approach our x-axis, is enough to get a really nice sketch of the left-hand side of our graph. Right-hand side, I'll just fill in. The reciprocal of -3 is -1/3. Reciprocal of -6 is -1/6. And I think that's close enough, because I'm just going to get closer and closer to the x-axis at that point. It's pretty much horizontal, which gives us our other horizontal asymptote, which is y equals 0. And for a basic reciprocal function where you just do a reciprocal of some function of x, you're always going to have y equals 0 as an asymptote. Right? Because if you've got something with x underneath, and it's like a polynomial, like a linear equation, or in our next video we'll see a quadratic down here, you can get this number getting to be something huge, and 1 over something huge, positive or negative, huge doesn't matter, 1 over something huge is going to approach 0, either from the positive side or the negative side. And so there you have it. That green, or that orange function there, sorry. This orange function here is h of x, which is 1 over our g of x, -3x plus 6. So if you're graphing the reciprocal of a linear equation, the easiest way to do it is to sketch the function and find your 0. And in this case, I gave one where the 0 just sort of worked out as a nice integer value. If you have one where it doesn't work out to an integer value, you just need to sub y equals 0 and solve. So let's say you had y equals -3x plus 2. Well, this one's not going to work out, right? Because 3, you're going to have a slope of 3 and you start at 2. But the way you figure out where your 0 is you just set y to 0. And so you set y to 0, and then you just do some, grade 8, grade 9 algebra. Bring the 2 over, -2, divide by the -3. So x is 2/3 then. And this x value that gave you 0 for y will then be the vertical asymptote of y equals 1 over, this function, -3x plus 2. Okay, that's reciprocals of linear equations in 10 minutes.